All right, this lesson is going to be using Pythagorean theorem on the coordinate plane. So you're going to be given 2 points and a line segment between them, and we need to find the distance of that line segment. And what we're going to do is we're going to build a right triangle and then use Pythagorean theorem to then find that missing side length. So let's take a look at a couple of examples here, and then we'll have you guys try some on your own. So let's go share screen. So what you're going to have is and you'll see here, 2 points and then a segment between them. Now we need to find the distance of this line segment. Well, because it's at a diagonal, we can't just count the squares because it's going through the squares. So we're not really getting a distance measurement. So what we need to do is we need to make a right triangle. And what we're going to do is we're on the coordinate plane. We're going to make our right triangle right there. So we're basically just going to go up and over, and we can do it on either side of that line. Well, when we do that, we create a right angle here in the corner. And that's key because that means this diagonal line is always going to be side C. And then if we look at sides A and B, the ones that make the little box, this one is 1, 2, 3 squares. And this one is 1, 2, 3, 4 squares. So the distance of side A and B are 3 and 4. So we're going to then use the Pythagorean theorem, and we're going to be looking for side C, and side C is going to be that missing side length that we need. So we'll plug in here 3 squared plus 4 squared equals C squared. 3 squared is 9, 4 squared is 16. Let's add them together because they're both on the same side of the equal. So I get 25 equals C squared. And then the last step is to get the C alone. So we're going to undo the squared with a square root. So C equals 5. So we're going to take that line segment and we're going to then make a right triangle, and we're going to put in the lines ourselves because we can do that using the grid. We're going to get a perfect right angle, and then we're going to use the Pythagorean theorem to solve. Okay, so let's take a look at another one here. So here is our right triangle. Here's our straight line. We're going to make our right triangle. So I'm going to go straight down and then straight over to the right. And that's going to create my perfect right angle here in the corner. And now I'm going to say, okay, well, this is side A and B. So here's side A. It's 1, 2, 3, 4, 5. And then side B is 1, 2, 3. So we're just going to travel along the grid. And this one travels down 5, and this one's over 3. Now, this is going to create something we haven't seen before. And this is where your calculator use becomes crucial. So let's plug into our Pythagorean theorem again. So our A squared is going to be 5 squared plus B squared, which is 3 squared, equals C squared. Remember, A and B don't really matter which one is which, but side C is always opposite the box. 5 squared is 25 plus 3 squared, which is 9, equals C squared. Add these together and I get 34 equals C squared. We're going to undo the squared with a square root. And then we get the C equals. Now I'm going to put a wavy equal sign in here because this one is not perfect. The square root of 34 is not a perfect square. And this is now the piece that's going to start to come into our Pythagorean theorem questions, is they're not all going to be perfect. So we're going to have to now round our decimal. Well, let's go ahead and let's stop sharing this. And let's go over to our calculator. This is the calculator on your Clever page. we're going to take the square root of 34. So I'm going to push the square root button. And I'm going to put 34 inside. I'm going to push enter. And over here on the right, you're going to see that this is a decimal. This is what we call an irrational number. It's actually a decimal that goes on and on forever and ever. All right, so what we're going to do is we're going to look at this decimal of 5.830951895, and we're going to round this. Now, depending on the directions, it'll tell you where you're supposed to round it. I'm going to have you round it to the 10th place, which is 1 decimal. So if I look here, I'm going to look at my 5.83. If I want to round to the first decimal place, I'm going to go out to the second one, which is 3. That 3 tells me that my 5.8 will stay at 5.8. Remember your rounding rules from earlier grades. If it's a 5 or higher, it would round up. So we're going to get 5.8 for our answer. So let's go back over to our problem here and say, okay, the square root of 34 was a decimal, and we're going to approximate it. So we do the wavy equal sign, all right, and we approximated that to 5.8. Not everything is going to work out perfectly like they have in the past, so we have to really be prepared for that. Okay, so let's go ahead and have you guys try one on your own here. We're going to go ahead and give you your triangle right here. All right, and I'm going to go ahead and I'll fill this in. We're going to go ahead and fill in our A and our B. On this one, side C. Remember, we're going to use the Pythagorean theorem. So go ahead and pause the video here for a moment, and then go ahead and count those squares and see what you will get for your A and your B, and then solve for your C squared. Now that you've done it, let's see how you've done. And if you need to follow along again, you can. So the first thing I'm going to do is I'm just going to figure out how long sides A and B are. So this one is going to be 1, 2, 3, 4. So that's 4. And then this one is 1, 2, 3, 4, 5. So this is 4 squared plus 5 squared equals C squared. 4 squared is 16 plus 5 squared, which is 25, equals C squared. Let's add 16 and 25, which will make 41 equals C squared. And then we're going to take the square root of 41. All right, and then remember, this one is not a perfect square, so that's going to make a decimal answer. As you used your calculator, your decimal answer should have been 6.403124. Anyhow, if we go out to 1 decimal place, it's going to round to 6.4. All right, and 6.4 is going to be side C. And if we look, 4 and 5 were sides A and B. Side C is 6.4, and that makes sense because side C always has to be longer, so that works out well for us. Now, there's one last thing that you're going to see with this particular type of problem. All right, and what you're going to get, and we'll go ahead and going to cover up part of this, but you're going to have a problem where they're just going to ask you to find the distance between 2 points. Now, these 2 points are ordered pairs, and if they want you to find the distance between those ordered pairs, all right, we can basically put them on the grid. Okay, now if we take a look here, and let's go ahead down to this one here, same thing, right? We've got 2 ordered pairs, and they're going to want you to put it on the grid. Now, what you're going to do when they have to put it on the grid is you're just going to plot your points and draw the line through them. Okay, so you'll notice that they just take the ordered pairs and then they plot the points. What's interesting about these examples, though, is they actually plotted the points incorrectly. So this one right here, this one actually should be 1, 5, because here's the 1, 5, and then this one is 5, -4. So they actually, whatever this problem, this example is, the points are actually wrong. So this is not 5, 1. This one is 1, 5, and this one is 5, -4. So let's go ahead and make our right triangle here, and let's see what we get for our answer. So I plot my points. And I get 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 4 squared plus 9 squared equals c squared. 16 plus 81 equals c squared. Add those together and get 97 equals c squared. And the last step is to square root. 97, again, is not a perfect square, so we're going to use the calculator. So let's come back over to the calculator here so you can see that. I'm going to say, okay, the square root of 97 is 9.848857. So we're going to go 9.84, and the 4 tells me that I'm going to stay put, so I get an answer that is going to be 9.8. So I'll come back over to our assignment here, and you'll see our answer of 9.8. Now, the big key is plotting those points. So when you get your ordered pairs, you're going to have to put those on the grid. Now, I have given you grid paper for your homework, and this is just plotting points. So this is review of probably 5th or 6th grade math. You're just going to take those ordered pairs, and you're going to plot them on the grid. So when you get your homework assignment, you're going to see just some plain old ordered pairs, and you're going to have to then plot those on there to get that answer. So again, just to recap and review, we are going to be finding the distance of line segments on the grid. And the way in which we're going to do that is we're going to make a right triangle out of each one of them and then use the Pythagorean theorem. This is the last big idea for Pythagorean theorem. After this big idea, we're going to sort of bring them all together and start doing some review and some prep. All right. Hopefully this one works out for you. Remember, all of our YouTube videos are posted on my channel, and you can also go to your weekly lesson plans to go look at anything that you need to get caught up on. And I encourage you to watch it numerous times if you need to. Guys, have a wonderful day, and I'll see you guys later.